Hey, hi YouTube, this is Nick. So it's my first time to upload some math context problem like that. If you like the problem here, please stay with me and I will post more problem like this in the future. So the problem that we are going to look is in HMMT 2016. It is letting us to compute this integration. And actually computing this integral is not very hard. We're just the method to compute this is just to eliminate those this term and this term, and to have our integral completely trigonometric, and then our integral will be very nice to do for us. So the technique for us to eliminate this integral, to eliminate this constant term, follows up the trigonometric term is just to apply the diagonal formula. Cosine theta equals cosine squared theta over 2 minus, okay, I think I shall skip the bracket here. Theta over 2 minus sine squared theta over 2, which equals 1 minus 2 sine squared theta over 2 equals 2 cosine squared theta over 2 minus 1. And sine theta, samely, equals 2 sine theta over 2 cosine theta over 2. Then the next thing we're going to do is just to substitute those equations into this integral to eliminate the constant term. Integration from 0 to pi, or numerator, will become like 4 sine theta over 2 cosine theta over 2, plus I think we're going to use this formula in order to eliminate the negative 3 term right here. So after substituting this equation into cosine theta, I think we'll be only left with negative 6 sine, negative 6 sine squared theta over 2. Okay, and on the denominator, because the term we want to eliminate is this, so we separate this 13 cosine theta term into 8 cosine theta plus 5 cosine theta minus 5 is theta, and then we substitute those equations properly to eliminate this negative 5 here. And what we're gonna do is just to let 8 cosine theta, we have to make this theta into theta over 2. So substitute this equation, 8 cosine squared theta over 2 minus 8 sine squared theta over 2, and 5 cosine theta minus 5 is just it's just negative 10 sine squared theta over 2. So what we will be left with is just integration from 0 to pi, and this is 2 sine theta over 2 times 2 cosine theta over 2 minus 3 sine theta over 2. Right. Okay. And on the denominator, we will end up with 8 times cosine squared theta over 2 minus 18 times sine squared theta over 2 d theta. Right. So after cancelling the scalar factor, we will end up with the integration from 0 to pi sine theta over 2 times 2 cosine theta over 2 minus 3 sine theta over 2. And in the denominator, we have 4 cosine squared theta over 2 minus 9 sine squared theta over 2. I think you all notice the denominator can be factored into, or can be factored by using this formula, right? So by using this formula, this term will be totally cancelled. So what we were left with is just I equals integration from 0 to pi sine theta over 2 over 2 cosine theta over 2 plus 3 sine theta over 2. Right. Let's make it much more nicer. X equals theta over 2, and this transfers our integral into, I think, 2 integration from 0 to pi over 2 sine x 3 sine x plus 2 cosine x dx. This is the integration now we want to look at. It just comes from this nasty integral. This integral is actually having some sort of symbolic method to solve. It's just to construct I0 equals integration from from pi over 2 sine x over 3 sine x plus 2 cosine x dx, and I1 equals 0 to pi over 2 cosine x over 3 sine x plus 2 cosine x dx. Right. So next thing we are going to do is just to construct a simultaneous equation like that. So firstly we have 3i1 plus 3i naught. Yes, 3i naught plus 2i1 equals integration from 0 to pi over 2 1 dx, right? Which equals pi over 2. And next integral we want to construct is integration from 0 to pi over 2 3 sine x plus 2 cosine x, and then we just find the derivative of this equation is 3 cosine x minus 2 sine x. There's of course another ways to construct different types of integration, but I find out that this way is the most convenient way. So this will be just 3i1 plus 3i1 minus 2i naught, right? Which is ln 3 sine x plus 2 cosine x. The integration bound is from 0 to pi over 2. Okay. And which is just ln 3 minus ln 2, which is just ln 3 over 2. Right. Let's assume this equation is equation 1 and this is equation 2. We want our integral, we want the result of I0, right? So we want to eliminate I1 here, which is just to use the equation 1 times 3 minus equation 2 times 2. So what we will get from this is 9i naught plus 4i naught equals 3 times this is 3 pi over 2 minus 2 ln 3 over 2, which is I naught equals 3 pi over 26. This is 13 times 2 is 26, divided by 2 over 13 ln 3 over 2. Right. And then we can immediately call from this, because our I equals 2I naught, so our I equals 3 pi over 13 minus 4 over 13 ln 3 over 2. Okay, that is the end of this that is end the solution of solving this integration. So if you find this interesting, please stay with us, and I will post more math context problems like this in the future. Thanks for watching.